Hey, welcome back. This is the last page of homework for your acid-base unit. We are going to be doing page 8 and 9 for homework tonight. It has very nice directions. Unfortunately, it didn't print in color on yours for you. But when acids react with bases, acids plus bases create water and salt. This was the most missed concept on last year's exam, so we tried to make some very clear notes that if you have a hydrogen, you are an acid. If you have an OH, you are the base. Water is always produced from the H and the OH, from the acid and base joining together to create water. Because remember, we can rewrite water as HOH. Therefore, you can see that the hydrogen and the hydroxide have joined forces to make a neutral solution called water. When we say that it forms a salt, it's not always NaCl. That's just our chemist go-to, because that's the one laymen are most familiar with, is what they put on their french fry salt. But it will always produce some sort of salt or ionic compound. So in the following examples, we have some directions. It says use the acids and the bases to make water. So in every single problem, you'll see we demoed some for you, you will have HOH. That is going to be your hydrogen and your hydroxide joining forces to create water. It will be easier to balance if you leave it as HOH, although we don't have to balance hip hip hooray on these. We just want to see that you can see what happens when a strong acid and a strong base join forces. It forms a neutral solution. For the salt, you're basically going to take the leftovers and join it. And when I say the leftovers, if we're taking out the OH and the H on every single problem, that means you need to join the other ions together. The positive ion is always listed first. So for here you've got magnesium and bromine, which will be MgBr2. That's what you'll write here. So for each problem, you'll take the Al, the positive 3, the I with a negative 1 here, crisscross, and you have ALI3. Now it does say what's left is the salt. Use the box provided to write the salts formula. Okay, this is the salts formula. This is what we're doing here. We look up the charges, we crisscross. So this is step 2, what I've shown you here. Circle the salt. So every time you take the leftovers and join them, that is called the salt. You extract the water here, the leftover is the salt. So we circle the salt, which in theory, if you set up water as that first one, whatever's over here on the right as a product will be your salt. It also says box in the acid. So anywhere I see an H, I would go ahead and box that in. And it says star the base. So anything with an OH should be starred. I'll do one more example and then we'll move to the next page. So here, K is +1, F is -1, so those would actually cancel and just give you KF. And we'll go to the next page. Okay. This is very much like the first page. I'll just leave you an example since you don't want to flip back and forth for an example. You pull out the water. And after you pull out the water, you're going to form the salt. So you're going to have barium, which is a +2 charge. And again, guys, I like to highlight that the hydrogen and the hydroxide are going off together to make that water. and the SO3, which has a -2 charge. These two cancel, and you'll be left with BaSO3. And again, the directions said that they wanted you to box your acid, star your base. I'm going to write that. Box your acid, star your base, and circle your salt. The following are neutralization reactions as well. Neutralization just means, this word neutralization is when you take a strong acid plus a strong base and you create water and salt. They just want you to practice your balancing skills here. For some of you, you're very used to seeing the polyatomic ions in parentheses. So if that helps you balance, absolutely do that. I would also suggest, since we're dealing with bases which are hydroxide, I would cross off water and I would rewrite HOH. There's 2 hydrogens here, but only 1 hydrogen here. And I know some of you are saying, what is she talking about? There's 2 hydrogens. I'm going to choose to balance the hydroxides separately than the hydrogens. So I would put a 2 here. That way now there's 2 hydrogens here and 2 hydrogens there. For my sulfate group, my SO4 group, there's 1 on each side. Now when I say each side, those of you who weren't here for the balancing unit, we're trying to make the number of atoms on this side exact to the number of atoms on this side. K, there's 1 here, but there's 2 here. So we should put a coefficient of 2 on this line so that there will be 2 Ks. So following along, there's 2 H's on both sides. There's 1 set of SO4s on each side. There's 2 Ks, and there's 2 OHs. So we would say that since all of them are equal to each other, that it is a balanced equation. Thank you for joining us for the last night of acid-base homework. You're expected to finish balancing the next 4 problems.